Trigonometric derivatives, quotient rule, Lagrange's notation. So, in a previous video I explained that the basics of the quotient rule, but the gist of it is that you have a function, I called it hx, and within that function you have two functions, one divided by another. In this case it's fx divided by gx. When you derive hx, you end up with the derivative of the first function multiplied by the second function minus the first function multiplied by the derivative of the second function all over the second function squared. So, now that you are up to speed, we can do an example. Okay. So let's say hx equals cos x over x cubed. That equals fx over gx. Function cos x over another function x cubed. So, if we divide the page, so now we write out the formula for the derivative, first derivative. Derivative of the first function multiplied by the second function minus the first function multiplied by the derivative of the second function all over the second function squared. So we need to find the derivative of the first function and the derivative of the second function. Derivative of cosine, negative sine x. Derivative of x cubed is 3x squared. So, if we input this, what we get is the derivative of the first function is negative sine x multiplied by gx, which is x cubed, minus fx, which is cosine of x, multiplied by the first derivative of gx, which is 3x squared, all over gx squared, which is x power of 3 squared. So, to make it neater, bring the negative out the front, but then we bring the x cubed out the front as well. Sine x minus 3x squared cosine of x all over x power of 6. Because x to the power of 3, when you square all that, you get x to the power of 6. Okay, so for another example, we have hx equals tan x over sine x plus 1. So, we know when we have a function over a function, call that fx and gx, separate the page and label them. Fx can be tan x, and gx can be sine x plus 1. So, now, write out the formula for the derivative. F dash multiplied by g minus f multiplied by g dash all over g squared. So we need to find f dash of x and g dash of x. Derivative of tan, sec squared x. Derivative of sine plus 1 is just cosine x. So we rewrite this, or input the values. We end up with sec squared x multiplied by sine x plus 1 minus 10x multiplied by cos x all over sine x plus 1 squared. Okay, that's enough. That's simplified enough for me. So, do another example. So, let's say hx equals 10x over sec x. Function over a function. So let's split the page and label them up. Fx is equal to 10x and gx is equal to sec x. Write out the formula for the first derivative. F dash x multiplied by gx minus fx multiplied by g dash x all over gx power of 2. So, like before, we find the derivatives of fx and gx. Derivative of fx is sec squared x, because derivative of tan is sec squared x. Gx is sec x, so g dash of x is sec x multiplied by tan x. Oh, that's a tight fit. So we sub this in. What we end up with is derivative of the derivative of the first function multiplied by the second function minus the first function multiplied by the derivative of the second function. All over the second function squared. So, if we simplify this or shrink it down, make it look a bit neater, we end up with sec squared multiplied by sec again is sec cubed minus 10 multiplied by 10 multiplied by sec is 10 squared x multiplied by sec x all over sec x squared. Now we can simplify this a bit further. There are other ways some people like to write it. I'm going to show you one because I feel like it, and I hope you learn something from it, obviously. But you can rewrite this as which is what it is. You can split it up because of the minus sign. And to continue on, what we can do is we can cancel out the 2 from the 3 and the 2 from the 1 that's up here. So what we'll end up with is sec to the power of 3 divided by sec to the power of 2 is just sec minus tan squared, that stays the same, we don't touch that. And then you have multiplied by sec to the power of 1 divided by sec to the power of 2. So you end up with just, so you get rid of that altogether, you take 1 off, power, and that's what you have. So this here is the first derivative of this function up here. Thanks for watching. I hope this helped.